Next, after we learn the asymptotic notation, now we want to do some examples. So we want to compare two growth functions and see which category each one belongs to. All right. So in this unit 2.4, I want to show you a sequence of examples, several examples. And also I want to use this chance to help you review calculus, algebra a little bit. We need to use it in many cases. Example number 1, 2.4.1. This is simple, it's very simple. Prove, you need to prove it. Show that n plus 2 belongs to big theta of n. First, you know the meaning of big theta. Okay? Both upper bound and lower bound. Okay? So in order to show this, you need to find both upper bound and lower bound. Okay? So let's find upper bound, lower bound. N plus 2. What constant multiple of n? Yeah, because g function is n. What constant multiple g of n we can use as the lower bound? Smaller than n plus 2. Okay? N plus 2. Let's start with from n plus 2. First, let's look at the lower bound. Okay? How about just n? Okay? We reduce that expression by 2. It is smaller and smaller than n plus 2. Okay? All right. Where n greater or equal to 0, this is true, right? Actually, always true, but we only consider n greater or equal to 0. We do not consider negative n. Okay? Yeah, your real size cannot be negative. Yeah. So think about our n is the data size, not a negative number. All right, so that's the n0. How about the upper bound? Now we want to find the upper bound. Okay. What multiple of n is greater than n plus 2? How about we replace n 2 by n? N plus n. How about that?
What is that? 1.
Right. But we can set n0. How about that? When n greater or equal to 2. Yeah, because we have freedom to choose n0, so we don't worry about n equals 1. Okay? We have that freedom to set n0. So this time we set n0 equals 2. So we have the upper bound, 2n. If you find both upper bound, lower bound, we get a big theta. Because that follows definition of big theta. You get a C1, 2, you get a C2, 1, you also have N0, 2. If you find all those important numbers, you find a solution. That's the solution. Very simple. The first example, no, very simple. But you need to get used to it. Okay? Example number 2. Show that NQ belongs to big omega of n squared. I think you know big omega, right? Lower bound. Constant multiple of lower bound. NQ greater or equal to some constant c times n squared. But you need to find n0. How about that? Okay. So lower bound. N cubed greater than n0 where n greater or equal to 0. Right? 0 they are equal, 1 they are also equal, but after n greater than 1, n cubed always greater than n squared. You multiply a number greater than 1. Yeah. So you can see N0 equals 0, C equals 1. You find the lower bound, okay? You find the lower bound, so you get a big omega representation. Can you find the upper bound? Can you find the upper bound C times another C times N squared greater than N cubed? Is it possible to get an upper bound?
If it's multiplied by something greater than n.
Can any constant greater than n? Can any constant? Remember, that C must be a constant. Greater than a variable n. It's impossible, right? Because our variable can be greater than any constant number. So you cannot find upper bound. There is no upper bound. Okay? So that's the reason here we do not ask you to find the upper bound. You cannot. The last example of today. Next time I will give you a few more. But today, that's the last example. Right. Example 3. Show that n plus 2 cubed belongs to big theta of n cubed. N cubed. Yeah. So this time, it's a little harder, but not too much harder. Not too much harder. Still, big theta, lower bound, upper bound, and also N0. Okay? Let's look at the lower bound part. Lower bound is easy, right? Similar to that one. Yeah. Yeah. Greater than N cubed. Okay. When N greater or equal to 0, that must be true. Upper bound, you can use the same way, right? Why? We cannot use the same way. We do here. Replace 2 by n. But we need to set n0. We need to set n0. Okay? After that, 2n greater than we take q. Okay? Because this is 2n, we need to raise to third power. Okay? 8 times 8 times. That constant, that 8 is another constant. So we get all those numbers we need. N0, because N0 should satisfy both inequality, we take the larger one. So N0 we take 2. 2 is larger than 0, we take 2. Then C1, C2, C1, 8, C2, 1. If you find these 3 numbers, you solve the problem. For big theta problem. Big theta problems. Basically, you find these things. Okay. So I will give you several questions, such questions in your homework assignment. So make you practice a little bit. Okay. You need to tell me the upper bound and lower bound, also tell me the N0. Okay. Similar to the examples we have seen here. Any questions regarding things? All right. So next time I have probably 4 or 5 examples complete this unit and to complete this lecture. Then we start lecture 3 next time.